Hey guys, I just wanted to make another video for you guys to have on one of the old reviews in case you had any questions on the new review. So this was the first e-learning assignment that we posted, so I'm just going to kind of go through the problems and try and explain the best that I can how to do each of them. Okay, so if we start with number 1 here, to determine the HK, so we're looking at the inside of the parentheses right here for our H value. And then we're looking at the outside right here for our K value. Our H value is always opposite of whatever the number in parentheses is. So we have positive 5, so then our H value is going to be negative 5. And then our K value is always whatever is on the outside right here, and that stays the same, so that's negative 4. So then if I do that same part in number 2 to find the HK, I look at positive 1, but since it's positive 1, I'm going to take the opposite, so that's negative 1 for my H value. And then if I look at this number on the outside here, that's negative 2, that's our K value, that stays the same. Okay, so now if we move on to end behavior here. So the first thing we look at to determine end behavior is our A value. If the A value is negative, it's going to go down to the right. If it was positive, it would have went up to the right. The next thing we do to determine the left-hand behavior is we look at the degree. The degree of this polynomial is 2. 2 is an even number. If it's even, it goes in the same direction as the right-hand behavior. So this will also go down. So now if we apply that knowledge to number 2 here, we look at our A value. Well, our A value, there is no number there, so it's an invisible 1. 1 is positive. Since A is positive, it's going to go up to the right. And then we look at our degree. Here our degree is 5. 5 is an odd number, so it's going to go down to the left. Okay, so next thing we're going to look at is width. So the first thing you're doing when you're looking at width is you have to look at the A value, but you're going to ignore the negative. You're looking at the absolute value of the A value. So we're going to ignore the negative. So 2/3. 2/3 is smaller than 1. If that number is smaller than 1, we're going to put wide. It's going to make the graph a little bit wider than if A was 1. Now, if we look at number 2, we notice there is no number there. It's an invisible 1, so it's not going to be wide or narrow. It's just going to stay the same. And then if that number was, say, for example, 5, 5 is bigger than 1, so we would say it was narrow. And then we're going to describe the shift here. So the shift comes from the HK. So the first thing I'm looking at is negative 5, which means we go left 5 units. And then we look at the negative 4, which means we go down 4 units. And then same thing for number 2. We see negative 1 in the x coordinate, so that means we go left 1. And we see negative 2, which means we go down 2. So now if we graph each of these, so for number 1, I'm going to go left 5, down 4. Both of my end behaviors are going down, and it's going to be a little bit wider than if A was 1, so it's not perfect here, but something like that. And then if we look at number 2, we're going to go left 1, down 2. And then we notice our end behavior is going up to the right, down to the left. It's not going to be any wider or more narrow than if A was 1, because A is 1. So it looks something like this. And again, those aren't perfect. if you graph those in the calculator or using Desmos, you would see exactly what they look like. Okay, so moving on now. Let's take a look at number 3 here. So these are our bounce pass problems. The first thing you need to do is you need to find the degree. In order to find the degree, you have to consider what form the polynomial is in. So I look at this, and that is in factored form right there. We can see each of the individual factors. We can see here, we can see here, and we can see here. So we have 3 factors, okay? And this one has an invisible 1 exponent, this one has an invisible 1, and same with that. If we add them all up to find the degree, when you have something in factored form, you add up all the exponents. 1 plus 1 plus 1 is 3. If I do that in the next one, notice I have an invisible 1 exponent with that x, and if I add them all up, since it's all in factored form, the degree would be 1 plus 3 plus 2 plus 2. So that would equal 8. Okay, so next thing I'm going to look at is the end behavior, and it's the same as in the first 2 problems. I look at the a value. The a value in this one is number 5, or is 5. 5 is a positive number, so it's going to go up to the right. And then I consider the degree. Since the degree is odd, 3 is an odd number, it's going to go down to the left. If I look at the other one here, since there's a negative a value, we're going to go down to the right. And then since the degree is even, we're also going to go down to the left. And now let's look at our x-intercepts. So our x-intercepts are the same thing as zeros. So what makes this polynomial 0? Well, the first thing that would make it 0 would be if I plugged in 0 to that first x. In this part right here, what would make that factor 0 would be positive 2. And then what would make this factor 0 would be negative 2. So those are our 3 x-intercepts. If I do that on the next one here, the first number that would make this polynomial equal to 0 would be if I plugged in 0 for that x. Some people might say, shouldn't I plug in 4? But 4 wouldn't work because if I plugged in 4 here, negative 4 times 4 would be negative 16. But if I plug in 0, negative 4 times 0 equals 0, and that's our whole goal, is to figure out what equals 0. If I look at this factor, negative 4 would make that 0. So yes, now it's essentially opposites. If I plug in 1 there, that would make that 0. And then if I plug in positive 5 there, that would make that 0. Okay, so now I'm going to move on to the bounce pass portion of this. So bounce pass. So first of all, to determine a bounce or a pass, it's going to pass through, the graph is going to pass through the x-intercept if the exponent on the factor is odd. So for example, all of the individual exponents on those factors are odd. If those exponents are odd, it's going to pass through each one of those x-intercepts. If I look at the second one here, and again, I'm looking at the exponents on each of the factors. For the first one here, at the x-intercept of 0, we see that the exponent on the factor is 1. 1 is an odd number, so it's going to pass through that point. 3 is the exponent on the next factor, and that's also odd, so it's going to pass through that point. Now the next factor, the exponent is 2, so it's going to bounce there since 2 is an even number. And at the last x-intercept, the exponent attached to the factor is even. Since it's even, it's going to bounce. So if the exponents are even on the factors, it bounces at that point. If they're odd, it passes through. So the last thing to do is to sketch the graph. So the first thing you do is you plot your zeros or x-intercepts. So we have ones at 0, -2, and +2. And then I like to draw in my end behavior next, because it kind of helps in case you make any mistakes with your bounce pass. You would notice it wouldn't connect. So we're going up to the right, down to the left. And again, this is just a sketch. It's not perfect. You would need to use the calculator or Desmos to determine how high and how low the graph is actually going. Okay, so now when I go through each of these points, I notice they're each passes. So I'm just going to pass directly through, and then my graph's going to look something like that. Now if I sketch the graph for the next one, we have some bounces, so it's going to look a little bit different. So first, plot your zeros. And then draw on your end behavior. So now I really need to pay attention to where I'm at here. So this first 0 is at -4, and I see at -4 it's going to pass. So when I draw this graph, I pass directly through it. The next 0 I approach is at 0, and we also have a pass. So I have to turn back around to get to that x-intercept, and then I pass through. Now the next one I'm looking at is 1. I'm approaching 1 on the x-intercept, or the x-axis now. So when I turn back around, I'm not going to pass through that point. I'm going to bounce off of it, since it says bounce there. And now I'm approaching the last x-intercept, which is 5. And notice at 5, it's also a bounce, which makes sense because I'm not going to pass through it, because look at your end behavior. I have to touch it and bounce off to connect the end behavior. So again, it's not perfect, but the graph would look something like that, especially if you're considering what's happening at the x-axis. Okay, so now we're going to move on to number 4. It says write a polynomial function that has the given characteristics. So first of all, we see our zeros, and we're trying to write a polynomial function. So I need f of x equals, and I have 5 different zeros. Well, in order to make a 0 at 0, I just need an x, because if I plugged in 0 there, that would be 0. And the next one, if I wanted a 0 at +2, well, the factor must be x minus 2, because if I plugged in 2 here, 2 minus 2 would be 0. And then, yes, essentially I just take the opposites. In order for a 0 to be at -3, I have to have x plus 3 as a factor. In order for a 0 to be at 4, I have to have x minus 4 as a factor. And in order to have a 0 at 7, I must have a factor of x minus 7. The last thing you need to do when you're doing these problems is you really have to check the degree that you're given. It says degree of 5, which makes sense here because we have 1, 2, 3, 4, 5. We add them all up. When it's in factored form, our degree is 5, so we're good to go. But say, for example, you were given a degree of 8, I would have to add exponents to some of these factors to make the degree total 8. And there's my answer. You do not need those ones there. I just did that to kind of show what the degree was. Okay, so now taking a look at this next one, now we have a graph and we have to write the polynomial function. So first of all, I need f of x equals. And in order to write this function, I'm really going to have to look at the x-axis and what the zeros are. So the first 0 I see is at -1. So that must mean that the factor is x plus 1, because if I plugged in -1, -1 plus 1 would be 0. I also notice that at this point right here, the graph is definitely not passing through. It's bouncing off of this point. So I need an even exponent with the factor, so I'm going to put a 2 there. And again, that's because it's bouncing at that point, not passing. So now when I look at my next factor, I see it's at 2, so therefore x minus 2 must be the factor. And this one is actually passing through. It goes right through 2, So we don't need to add an exponent because the invisible exponent is 1. 1 is an odd number. And then at positive 4 here, our factor would be x minus 4. And since this point, it also passes through, we do not need to add an exponent since 1 is already an odd number. Odd exponents signal that it's going to be a pass. The only other thing that I need to consider here is I need to consider that the graph is going down to the right. Anytime a graph goes down to the right, we add a negative out front. Because remember, a negative a value shows that it's going to go down to the right. Even degree would show that they're both going down, which makes sense here because our degree would be 2 plus 1 plus 1, which would be 4, which is an even number. Okay, so moving on to the next one here. Both of these problems are pretty similar. We need to write the vertex form for the given function. Okay, so we have f of x here. And first of all, we see that there is a number out front. Anytime there is a number out front here, what we're going to have to do is we're going to have to take that number, whatever it is, so negative 2, and bring it out front. Then what you do is you divide each of the first two terms by whatever that number is. Negative 2x squared divided by negative 2 is x squared. And then 4x divided by negative 2 is negative 2x. We're going to add a blank spot here and to the other side. And then the minus 9 stays on the outside. Now, in order to get the number that goes in this blank spot right here, the first thing we need to do is we need to kind of complete the square here. So you might remember how to complete the square to solve a quadratic. It's just a little bit different. So the first thing you do is you divide the middle term by 2. When you take negative 2 and divide that by 2, you get negative 1. So I would have x minus 1. And what you do with that negative 1 to get the number that goes in that blank spot, you square it. Negative 1 squared means negative 1 times negative 1, which is 1. To get the number that goes in the blank spot on the other side, you don't just put 1 there. Since you took out that negative 2 at the beginning, you have to multiply these two numbers. So 1 times negative 2, which is negative 2, and that goes on the other side. So again, that's coming from 1 times negative 2. So now I rewrite everything that I have. Plus negative is the same thing as minus. And your final step here to get vertex form would just be add and get the f of x by itself. So we're going to add 2. So our final answer is negative 2 times x minus 1 quantity squared minus 7. And that would be vertex form right there. Why it's vertex form? Because you could clearly see the vertex is 1, negative 7. Okay, so now we're going to do the next one, which is pretty similar. So we set it up the same way. F of x plus blank equals whatever the a value is, or the number out front here. You take that out front and you divide each of the first two terms by it. So negative 5 comes out front. Negative 5x squared divided by negative 5 is x squared. Negative 20x divided by negative 5 is positive 4x. Be careful with your signs there. And now I add a blank. And the last term, the constant, always goes on the outside. You don't divide that last constant by this number right here. Okay, so to get the number that goes in the blank, you divide the middle term by 2. So when we divide the middle term by 2, 4x, or 4 divided by 2 would be 2. So I'm going to write x plus 2 quantity squared. And now to get the number that goes in the blank, you always take the middle term, divide it by 2, and square it. So when we divided it by 2, we got 2. 2 squared is 4. And remember, we don't put a 4 on the other blank. What you do is you multiply this times this. 4 times -5 would be -20. That goes on the other side because you're actually adding a -20 to that side, because you would have to distribute the -5 if you kind of wanted to simplify the right side. Okay, so now what I'm going to do is I'm going to copy down everything I have. So f of x plus negative is the same thing as -20 equals -5 times x plus 2 quantity squared minus 1. And to get f of x by itself, we're going to add 20 to both sides. So therefore, our final answer here is f of x equals -5 times x plus 2 quantity squared, and -1 plus 20 is plus 19. So there's our answer. Why it's in vertex form, you can easily see the vertex is -2, 19. Okay, so moving along here. We're now on using synthetic division to show that x equals 6 is a 0 of the third degree polynomial equation. So first of all, we're given that x equals 6 is a 0. So what we must do is first use synthetic division to get the other zeros. So I put 6 in the box, and then I copy down the coefficients of the polynomial. So there's an invisible 1 in front of x to the third. We have -10 here. We have 19. And we have 30. After that, what we do is we bring the first number down below the line, which is 1, and then you take 1 and you multiply it by 6. 1 times 6 would be 6. That goes in the next spot, and you always add straight down. -10 plus 6 would be -4, and then I do the pattern again. -4 times 6. -4 times 6 would be -24. Add straight down, positive 19 plus -24 would be -5, and then I multiply. -5 times 6 would be -30. Add straight down, we get 0, which makes sense because x equals 6 is a 0, so we should get 0 when we do our synthetic division there. So now writing this as a polynomial, since we started with a third degree polynomial equation, when you do synthetic division, it brings it down 1. So we're now at a second degree polynomial equation of 1x squared minus 4x minus 5. So you just go down 1 from what that is. And now we need a factor. So we're thinking what multiplies to -5, but when we add those same two numbers together, we get -4. So the two numbers would be -5 and 1, because -5 times 1 is -5, but -5 plus 1 is -4. So therefore our factored form would be f of x equals x minus 5, x plus 1. And now our zeros here. Whoops, actually I forgot one part in the factored form. With your zeros, since you're given a 0 of 6, you're told in the problem that x equals 6 is a 0. We need to add that to our factored form. Our factored form here would actually be an x minus 6 added to it, because x equals 6 is a 0. So we need 3 factors here, unless there was a bounce at one of them. So there's our full factored form. So one way to not forget that is you can always just write that down here at the end. You know one of the real zeros is automatically going to be 6. We were given 6 is a 0. We showed it was a 0 through synthetic division. And now we need our other two. Well, 6 clearly makes this one 0. What makes this factor 0 would be -1. And what makes this factor 0 would be +5. So there's our 3 zeros. Okay, so we're on to number 7, applying the rational zero test. Okay, so if you forgot what the rational zero test says, it says that the possible rational zeros of a polynomial can be found if you take plus or minus all of the factors of your constant of c, and you divide them by all of your factors of your a value. So if we do that here, it's actually pretty easy since these numbers are both prime here. The factors of our constant 3 would be just 1 times 3. Those are the only numbers that are factors of 3 since it's prime. And the factors of 2, again, it's prime, so it'd just be 1 and 2. So the actual rational zeros, or possible rational zeros, sorry, would be 1 divided by 1, which is 1. So we have plus or minus 1. I got that from there. Or we could do 1 divided by 2, which would be 1/2. And then we have 3 divided by 1, which is 3. Oops, sorry. And 3 divided by 2, which is 1.5, or 3 over 2. If any of those fractions weren't simplified, you would need to simplify them. And if any of them were repeats, you don't have to list them more than once. But right now we have a list of, a lot of people would say it's 4 possible rational zeros, but it's actually 8 because it's plus or minus each of these. So we have 8 possible rational zeros. In order to, if we wanted to figure out the actual zeros, we'd have to plug, we would start with 1, plug in 1 into the original polynomial, see if you get 0. If you do, then you can use synthetic division and then eventually factor that polynomial. Okay, so last page here. So we're looking at number 8. It's asking for the horizontal translation. Left or right, how many units? Well, we're definitely going to have to look at our vertex here, our hk. So since we have plus 2 inside the parentheses, we know that our h value is negative 2. Since we have negative 5 outside the parentheses, our k value would be the same thing, negative 5. And this tells us our translation here. Negative 2 is our horizontal translation. We would go left 2 since it's negative. And our vertical translation would go with the y coordinate here. So we would go down 5 units. Now looking at the width, this is similar to the first couple problems. Remember, we do not look at this negative. We consider the absolute value of that, which is 1/2. It's always positive. So 1/2 is smaller than 1. If the number is smaller than 1, we are going to say that it's wide. If that number was, say, for example, 10, that's bigger than 1, we would put narrow. And then last part here, end behavior. Since the first thing we look at is our a value, if the a value is negative, it goes down to the right. And then since the degree is even, it's going to go in the same direction. It's also going to go down to the left. Another way you can write end behavior is right hand and left hand. Or if you want to put right end behavior, left end behavior, same thing. So the right hand end behavior, we could say that it falls because it's going down here. And then the left hand end behavior also falls. If one of them was going up, we would say rises. So that's another way you could write it if you like that better. Okay, guys, that's it for this review. Hopefully this helps. And if you have any questions, feel free to reach out to me and just